wondered how people max out weights at the gym and they don't break? Well, we're about to tell you. Today we'll be focusing on the lat pull-down machine. As you can see, there are multiple selection slots that you can put the key in to select a weight. Some key assumptions are that there will be no friction in the system and the key is too short to experience bending moment, so we will analyze double shear. Here's an example of how it works. I'm going to select my weight, 100 pounds, and hold down.
Using the dimensions of the key, we can calculate the factor of safety with the Goodman criteria. To find the adjusted endurance limit, we use the Marin factors based on the features of the key that we got online.
To calculate the factor of safety, we have to work out our tau max and our tau min. Our tau max can be calculated using the equation 4v divided by 3a because the key is a cylindrical shape. Our tau min is equal to 0 because the key won't be always in use on the lat pull-down machine. This means that our tau A and our tau M are equal to each other. Using the SE and the SUT values mentioned above, we can work out our factor of safety to be 21.8. Plotting this on the fluctuating stress diagram, we see that our value lies within the infinite life region, as we've just mentioned, given our factor of safety was 21.8. We use the value of SSY and 0.67 SUT as the key is in shear.
So here we have a video of Miner's rule, where we're using it to calculate the number of cycles that the machine can experience before failure. So there's 3 types of loading: light, medium, heavy. And then we're setting out the table for calculations with cycles per day, load, tau max calculated using 4v over 3a, tau alternating, and number of cycles. You can see that number of cycles for the light and medium load are 1,464, and for the heavy it's 732, with the loads in the following column. We calculated the number of cycles to be around 8.5 times 10 to the 13 for the light, 1.92 times 10 to the 12 for the medium, and 1.7 times 10 to the 11 for the heavy. Next up, we're using Miner's rule, which is the sum of number of cycles per day over total number of cycles that this part can experience, which gave us around 200 million days to failure.
To conclude, we've defined our failure as when the pin shears. However, we've calculated this to be very unlikely given the factor of safety is 21.8 and there are 200 million days until failure. In the future, we could analyze, for example, cases like when the weights are slammed. However, given the calculations and the values acquired in this part of the project, we can now understand why people can max out weights at the gym without the machine failing.